All right, class, we're on the second page of the notes. Yay, math? All right. All right. The team, now we're going to apply the bar model method to solving problems with percents. And that can mean you're given a percent, you got to find the part. You're given a percent, you got to find the whole, or you're given a part and a whole and you have to find the missing percent. So the method to doing this is regardless of what the problem says, you always start with writing the bar model percent at the bottom. You start with 0% and you have 100%. And why these bar models are important is because you're going to be asked to solve problems with bar models, meaning they'll give you several bar models and you have to apply it. You have to select which one applies to the problem you're working on, or they'll give you several problem situations and you have to figure out which problem situation applies to the given bar model. So it is important to be able to use these. So once you have written the bar model percent, then we're going to read our problem. The team had 10 of their 20 players. What percent of their players did they have? So the word, like we used to use with the one, is players. If they have 0%, how many players they have? 0 players. Do we know, based on the information given, if they have 100% of their players, how many players that is? Because it says of their 20 players. Okay, so with a percent bar model and a number like 20, what would be a percent we can easily determine? 1/2. Okay, how much percent would that be? 1/2. We can break it into two. 50%. Okay, so how would you determine what number 50% of the players is? Somebody raise your hand, please. Okay, go ahead. Split the total number of players in half. That's literally what I did. So that would be, what's another way you could say that? What's another way you say that, you smart girl over there? Divide it by 2. 20 divided by 2 is 10. So in the middle would be 10. And that's actually, the team had 10 of their 20 players. What percent of the players do they have? We've got our answer at 50%. Okay. Number 2, I want you to take a minute and set up this problem. Set up this problem. Draw your own rectangle. Let's see how good a rectangle drawers you are. All right, so I drew a very awesome rectangle. Okay, what goes at the bottom of the rectangle? And over here on this side, 100 what? Percent. So Marcus sold 15 out of 60 cars this month. What percent of the cars did Marcus sell? Well, if Marcus sold 0%, how many cars would that be? I'm going to label this at the top 0. And if he sold 100%, can we know that from the information given, class? Yes, 60 cars, because it says of 60 cars. Okay, now he sold 15. So 15, if we have 60 here, what's half of 60? 30. So 30 is how many percent? 50%. Now, so 15 is between 0 and 30. Okay, and you would say it's, Zoe? Half of 30. So 30 is 50%. How much is 15 cars? Half of 50%. 25%. 25%. Okay. Okay. All right. Let's move on to number 3. Haven went to the store to buy a sweater. It was on sale for 25% off of $52. What was the amount she saved on the sweater? What do we do at the bottom? 0 and 100%. Okay. We're talking, we're buying a sweater for money, right? So we'll have, if we have 0%, how much money is that? $0. And if we have 100%, can we know how much money that is? You say 52 because it says off of 52. So we can assume it's a $52 sweater. Okay. Now, would anybody like to share a strategy for finding what amount she saved on the sweater? Trey, thank you. Okay, so Trey says divide 52 by 4, and so what Trey's doing is since we want 25%, 25% is here. That's where we want to be. 50% is here. 75% is here. So Trey's going to break this $52 into 4, and then that's going to help him figure out 25%. So 52 divided by 4 is $13. So from that, we can determine that $13 is 25%. So what was the amount he saved on the sweater? He saved 25%, so he saved $13. And this follow-up question, the problem is not, in this follow-up question is not how much he saved, but how much was the sweater after the discount. So what will we do there, Zoe? I mean, Jenny. So you mean subtract 52 minus 13? So what is my sweater going to cost after the discount? How much is it going to cost? $39. Good. Okay. Okay, moving on. Number 5. David made 40% of his free throws when playing the game last night. If he attempted 20 free throws, how many did he make? Well, let's make our bar model. Okay, and at the bottom, as always, we put 0 and 100%. And at the top, we plug in our facts about these free throws. Okay, he said he made 40% of his free throws. So he made 0%, he made 0 free throws. And I'm going to put my 40% right about there. Okay, now he attempted 20 free throws. So what does 20 reflect? Is that the 40? Lucas says 20 represents 100% of, because it says he attempted 20 free throws. So what would be a strategy for finding 40% of 20? What kind of bar model does this look like it's going to break into to help us solve it? Okay, Tegan, say it. 20s, okay, like 20, like, okay, so it'd be 20, 40, 60, 80, 100. All right, let's go with that strategy. Okay, so if I do 20, 40, 60, 80, I broke it into 1, 2, 3, 4, 5. So what kind of math would I do from there? What kind of math do I need to do to find out what number is going to go at 40%? Somebody says divide 20 by 5 because I'm going to break it into fifths. Okay? So that means the answer is 4. Okay? 4 goes where, though? Where do I put 4? Where do I... Up here in the second row. At 40%? Do you agree? Do y'all agree or disagree? There's some disagreement. Okay, 4 represents how much each fifth is. 4, 8, 12, 16, 20. So if I go all the way to 40%, I'm at 2/5, and so that represents 4 and another 4, so 8 fifths. Okay, how many did he miss? So I'm going to take 20 minus 8, and that gives me 12. That's the follow-up question. Okay, get that. We're just trying to emphasize keep reading your problems because that may be key. Okay. Okay, we're going to do one more and then I'll let you do the other one on your own. Mr. Ford has 4 cans in a box and the box was 20% full. This is a different kind of problem you're going to find. How many cans will the box be able to hold when it's completely full? So we start with 0, 100%, and we're talking about cans. So Mr. Ford has 4 cans in a box and the box is 20% full. So we're going to write down 20%. And how much is 20%? 4 cans is 20%. So how many cans will be in the box when the box? That's all the information we're given. We're given 4 is 20%, and we need to find out what is full. So full goes where? What percent is full? 100%. So that's what we're trying to find out right there. What is full? So this is, while in the previous problems we've had to simplify to find our answer, in this problem we're actually going to find an equivalent proportion or expand it. So how does 20% become 100%? Class? Times 5. It is a scale factor of 5. And what we do to the bottom, we have to do to the top. So our full box is 20 cans. If he has 4 cans, how many more cans does he need to fill the box? Keep reading. And I'm sorry, 20 minus 4 equals 16. He needs 16 more cans. Okay. Number 9 is all on your own. The bar models are important, and they help us also to start to create the proportions we'll need for the future to solve the more advanced problems.